This is one of the oldest puzzles known to man. It is the Towers of Hanoi, a puzzle which has been known in Southeast Asia since antiquity. It has almost as distinguished a history within the young science of artificial intelligence, as many of the earliest discussions of problem solving were carried out in terms of this ancient puzzle. For this reason, it was adopted as the logo of the Interlisp-D programming system, a system which provides Interlisp's symbolic programming power in a flexible, interactive, personal computing environment. To illustrate its range and power, we will review 4 significant applications of Interlisp-D, which exploit its facilities in characteristically different ways. One of the principal uses of Interlisp-D is in basic research on artificial intelligence. Typical of such applications is that of cognitive and instructional sciences visiting scientist, Stanford University professor Doug Lenat.
One of the most fascinating topics in computer science and artificial intelligence today is learning, the acquisition of knowledge. Sometimes that takes the form of transfer of expertise between some domain expert and a program. Sometimes that umbilicus is severed and it takes the form of a program being exposed to an environment about which it has to learn and form its own concepts. And it's that latter situation that I've been doing research on. Originally, about 5 years ago, I wrote a program called AM that worked in elementary mathematics, that started with about 250 heuristics, rules that guided it to perform plausible actions as it searched for interesting new mathematical concepts, gathered data about them, noticed conjectures involving them. The trouble was that AM's behavior began to degrade after a while. It was very exciting when it discovered cardinality and number theory, and eventually concepts such as prime pairs. But as it began to work on them, it began to thrash. Now, why was that? The basic problem is that this concept of prime pair is defined in terms of this one, which is defined in terms of this one, and so forth, down to a concept about which AM had a few heuristics. These few weak general set theory heuristics weren't powerful enough to constrain AM when it was working in number theory. So if you think of knowledge as comprised of facts, objects, operators, terms, jargon, textbook knowledge, and heuristics, informal judgmental knowledge, the problem with AM was that it wasn't capable of discovering that second kind of knowledge. It wasn't capable of discovering heuristics. And therefore, we built a new program, Eurisko, with that goal in mind. The key to Eurisko is every heuristic is represented in exactly the same way as the mathematics concepts and the other domain-dependent concepts in the system, so that the heuristics operate not just on mathematics concepts and geology concepts and biology concepts, but the heuristics can operate on and modify and synthesize heuristics. That's the real source of power. Now, you might ask, how exactly do new heuristics come into being? You could imagine them coming by specializing some general heuristics that you have, or by generalizing, by compiling the hindsight you've acquired into new heuristics which, if only you'd had them sooner, would have gotten you to your current state that much faster. Or by analogizing, taking a look at heuristics from other fields and paths that you followed to get heuristics in other fields, and seeing if any of that carries over into the current situation. Now, the answer to this question is we don't know which of these methods is the most valuable, and we don't know exactly how each of these methods works. That's the reason why we've built Eurisko, an experimental vehicle, an Interlisp program that embodies these methods, that goes off and tries to discover mathematics concepts, occasionally abstracts from that experience new heuristics, and thereby beats this kind of thrashing problem that AM suffered from. Okay, without further ado, let's go over and take a look at the Eurisko system and see how it discovers new heuristics as it discovers mathematics and other concepts. The Eurisko screen is divided into several windows. Starting with the one on the right, we see the list of topics that Eurisko knows about, including mathematics, oil spills, programming itself, and under that, the list of tasks on its current agenda, tasks which are plausible, promising things for Eurisko to spend time working on. Moving to the left, we see the current task that happens to be selected and is being worked on. And below it, the heuristics which are being applied to that current task. Down at the very bottom, you see rapidly flickering numbers, which are the numbers of heuristics which are potentially relevant to working on the task. Just above is the English abbreviation for the heuristic which is currently firing. And off to the left is the concept which is being worked on. In the current case, you see that the concept is H1, that is itself a heuristic. So we have heuristics such as H4 being applied to other heuristics, in this case H1. Let's interrupt it and take a quick look at something it just did. In heuristic H12, in a slot called then compute, it changed an and to an or. H12 was a heuristic which said, if you've gotten into a bad situation, then create several new heuristics, any one of which would have been capable of avoiding the situation if only you'd had it sooner, and presumably avoiding similar situations in the future. What Eurisko has just done up here, by changing and to or, is to create a new heuristic, H12-1, which is very similar to H12, but instead of creating several such new heuristics, it will only create one new heuristic. It may very well turn out that H12-1 is a more useful heuristic because it doesn't create so many new ones. And if that's true, eventually H12 will be subsumed and destroyed. At the moment, Eurisko is executing a heuristic to see if any known heuristics are equivalent to H12-1, the new one it just synthesized. None of them are quite equivalent, and it accepts it as a brand new heuristic.
At the opposite extreme from Lenat's abstract symbolic